Hi everyone, welcome back to Newegg TV. My name is Paul and welcome to part one of our three-part series on how to build a computer. I was just checking out our old Build Your Own PC tutorial and we decided it's time for an update. So part one is going to be basically PC theory. What are the parts in a computer? Part two is going to be how to build, and we're actually going to be putting together a couple systems for you. Part three is going to be about software, installing an operating system, and doing the final touches to get your PC all set up and running after you've done the build. So for part one, we're going to start at the most basic level. What is a computer? Well, if you've built a computer before, you probably know the answer to that question. And I'll be honest, if you have built a computer before, there might not be a whole lot for you to learn in this video. But if you have friends who ask you how to build or how to fix or you need any help, give this video to them. Hopefully this will be helpful. If you haven't built a computer before, well, a computer's right here. Chances are you're probably using one right now to watch this video anyway. But for the purposes of this video, we have the computer case itself, we have monitors, and we have a couple human interface devices here, mouse and a keyboard. You can also have printers and that sort of thing. And since peripherals like the monitor, the mouse, and the keyboard don't necessarily really affect the performance of the computer, what we're going to focus on for these videos is just the computer itself, the case and the components that are inside. Now, a computer system as a whole might seem complex and intimidating to a lot of folks, so I've come over here to this light switch to show at the most basic level how a computer works. And that's like this: off and on. Now, computers operate on electricity, and electricity, just like our light switch over in the corner there, can only have two states, on or off. That's a pretty basic set of information. But what people have done is they've built a language on top of that. The language is called binary. It is solely zeros and ones, and those zeros and ones simply correspond to an electrical signal being on or off. A 0 or a 1 is referred to a bit of data, and a group of 8 of those is referred to a byte of data. And you're probably familiar with terms like megabyte, gigabyte, terabyte, especially if you've worked with computers at all. But apart from that, all sorts of other languages have been built on top of that, eventually up to the level where you get to operating systems and the actual interface that you see here that lets us do all of the fantastic things that we can do with computers. A lot of complex stuff in between there, but at the most fundamental level, all you're really dealing with is an electrical signal being on or off, and a computer inside there, or a processor I should actually say, that does addition, subtraction, and multiplication. Now that we've mentioned that, let's actually get into the computer case itself and go over all the different components. So here is our list of the 8 essential computer parts that are necessary for any computer build. We're going to go over these one at a time and just give a brief explanation of what each one is and what it does. First on the list is the computer case, and this is probably the most accessible for anyone who's never built one before. Obviously, a computer needs a case to put all the parts in to keep them protected, and here's an example of one right here. A case not only protects the components that are inside, but it also provides adequate ventilation because computer parts tend to get hot. Heat is the enemy of computer parts, and you want to make sure that you have lots of airflow. And generally with a case, the air enters from the front part right here, flows through and up, and exhausts in the back. This is known as a tower style case. There's other versions available, but for our purposes, since these are the most prevalent, this is what we're going to be showing you folks today. Next up on the list is the power supply, and here you can see in our already constructed computer the power supply residing right down there at the bottom. Sometimes they can be mounted at the top as well, again depends on the case. But the power supply's job is to take your standard AC current coming from your wall and basically convert that into usable power for all the different components in the case. I've started off with the case and the power supply in this list for one reason in particular, and that is that the case and the power supply, generally speaking, won't really affect the performance or speed of your computer. In fact, you can remove most of the other components from this case and the power supply. You can put them into a different case with a different power supply, and your performance would not change at all. Next up on our list is the motherboard, and the motherboard really performs the essential job of tying all the other parts in the computer together. In our pre-built computer over here, the motherboard's installed there at the back, but actually all the other parts that are plugged in are mostly blocking it. But essentially a motherboard will have a socket for your processor that you plug in right there. It will have these long slots where you plug in your memory. It has a couple power plugs where you plug in the power from your power supply. And then it's got some add-on slots down here where you plug in a video card, maybe some additional add-on cards like a TV tuner. Down here at the bottom, you have plugs where you route cables to the front of your case to operate things like the on-off switch. And then finally at the back, are these ports which are exposed at the back of the computer, which allows you to plug in your mouse and keyboard as well as your sound, your network, and anything else that goes into those input-outputs on the back. The fourth item here on our list of parts is the CPU, also known as the Central Processing Unit. And it resides right here underneath the processor's heatsink fan. The heatsink fan is very necessary because in doing the addition, subtraction, and multiplication that the processor does, it gets very hot, and you got to make sure that you vent the heat off of it. There are two main companies that manufacture desktop processors, AMD right here and Intel right there. I'm going to leave it at that. If you want to go ahead and research, there's lots of information on the internet comparing and contrasting the two. They have lots of different processors to choose from. We'll get back to that when we go over choosing the parts. But there is a fundamental difference between these CPUs themselves in that Intel, for the past few years, has been using a socket that they call LGA. And if you can see the bottom of that, but these have gold contacts and not pins. Now, I'll show you guys real quick our AMD processor right here. And AMD is using a more standard method for processors that's been around for a while, and that is that they have the pins on the processor themselves. When you're handling processors, be very careful because they are delicate and they are the most expensive part of the computer usually, unless you have a really high-end video card. For the sockets themselves, and let me set this down real quick. For AMD, as you can see, the socket that the processor drops into has a lot of little holes that those pins slot into. And for Intel, as we can see with our LGA socket right here, you can see all those little pins are on the motherboard itself. In either case, you always want to be really, really careful that you never bend any of those little pins, because one bent pin will mean your computer won't work. But as long as you take the proper precautions and you're careful when you're doing your installation, you should not have any problems. Before we move on to our next part, there's one last thing. This is the second thing that you get in the box along with your CPU. That is a heatsink fan. The one that comes in the retail box for either AMD or Intel processors is known as a stock heatsink fan, and you can use that. It works just fine. It's got a contact there on the bottom. It cinches down on top of this little heat spreader on the CPU, and just like you can see in our case right up there, you get a nice good contact and it disperses the heat. Now, one thing that a lot of people like to do, especially people who build their own computers, is they overclock, and that makes the processor get a lot hotter. If you're overclocking, you might consider purchasing an aftermarket heatsink fan. Here's a good example of one here. This is something that you purchase in addition to the retail box processor. Basically, you use this instead of the stock one that comes with the processor, and generally speaking, an aftermarket heatsink fan will give better cooling performance, and oftentimes they can be quieter as well. Next up on our list of components is memory, and you can see 3 sticks of memory installed to the motherboard right there on our pre-built system. Memory, in its most basic form, looks something like this. This is known as a DIMM. Memory is also known as RAM, Random Access Memory. Once plugged in, the function of memory is basically to allow a repository where data can be stored that needs to be accessed very, very quickly. When you load up a new program on your computer and you have to wait for a few seconds for the program to start up and appear on screen, what's that doing is it's loading a bunch of information onto the memory so it can quickly grab that, display it on the screen for you. This is a simple stick of memory, and you can see the actual little modules right there on the stick. There is also memory such as this one right here that has a heat spreader on it, and that's simply to help disperse the heat because these little memory modules do tend to heat up a bit. And number 6 on our list of essential components is the video card. And some of you folks might be saying, actually, Paul, the video card is not necessarily essential. And you're correct, because some motherboards, like this nice little mini ITX motherboard here, actually have video integrated. So part of the motherboard is you have your video outs right here. There's a DVI, there's an HDMI out. But if you don't have a motherboard that has video on board, or if you just want much better video performance, you're definitely going to want to get one of these, which is known as a discrete video card. It's separate. It plugs into the PCI slot on the motherboard, like you can see this one installed right there. I'm sorry, I should say PCI Express slot. And then at the back here, you can see your video outputs. You got an HDMI, an analog, and a DVI on this one. That matches up with the back of your case, so you can plug in your monitor to that and output a video signal to your monitor from your video card. So 2 options for that. You can purchase a motherboard with the video integrated, or you can purchase a motherboard with the correct PCI Express slot and purchase an add-on discrete video card like that one. The next item on our list is storage, and actually a couple of years ago I would have just called this category hard drives, but there's a new development called SSDs. That's another option for folks who need storage. But in any case, you need storage on your computer. The memory that we referenced is temporary. Stuff that's loaded onto there is only there as long as your computer on, and then is on, and then it's flushed out. Hard drives, on the other hand, are permanent storage, so stuff that you load on here will stay there even if your computer's off. This is a mechanical hard drive. There's spinning platters inside, a little read head that will go over and read the data off of it. This is a 3.5-inch drive as well. But if you have a computer right now, chances are you have a mechanical hard drive in there. The second option here for storage is SSDs. SSDs use NAND flash memory. There are no moving parts inside. They're very, very fast, but since the technology is newer, they're generally a bit more expensive, especially price per gigabyte wise, than their bigger and more old school mechanical hard drive siblings. And the last item on our list of essential PC components is the optical drive. This right here is a DVD burner. You can also get Blu-ray readers and writers these days as well. But basically this will allow you to take CDs, DVDs, Blu-rays if you have a Blu-ray reader and read them, write to them if it is a burner. And this is important for a few different reasons. The main important reason is when you initially load an operating system onto your newly built computer, it will generally come on optical media like this CD that's here, usually a DVD. This is just a blank CD. But you need to take that, load it onto your optical drive, and then it reads the information off of here through the computer and loads it onto your storage, whatever type of storage drive that you have. Also, after you've got your operating system loaded up, you can use this to play back CDs, DVDs, Blu-rays, especially if you connect your computer to, for instance, a large screen television, you can use it as a media player. So now that we've gone over all of the parts for a computer, we're going to get back to the main topic of this video, which is how to build a computer. The first step in building a computer is choosing your components, and in my opinion, that's actually one of the most fun parts of building a new computer. So we're going to go back down the list, and for each component, I'm going to give a few tips to help you choose the best components for your needs. Starting off with the computer case here. This is the Corsair Obsidian 650D, and this is the case that we have chosen for one of our two builds for the part 2 video. There's a few things that I really like about this case. Starting with the side panels, you notice there's a couple latches right there, and that's all you got to do to remove the side panel. A lot of cases will mount on the back with thumb screws that you bolt in right there. That's another good option. And then the cheaper cases will just have standard Phillips head screws there. But that just lets you get into the case more easily, especially if you're going to swap out parts or anything. At the top of this case, we can see an exhaust fan, and this is a 200mm fan. I really like larger fans because they can spin at lower RPMs, but they still move a lot of air, so they stay really quiet. Another thing to consider is just your cooling in general. And as we mentioned earlier in the video, generally you have intakes up here in the front or at the bottom, and the air moves through and up the case and exhausts at the top or the rear. Now, wherever you have intakes, you're going to have dust that builds up, and that's another reason why I like this case, because it has this little easily removable front panel dust shield, which is where your dust will collect, and you can easily just pop that off to clean it out. Some other things that cases might have, like an example right up here at the top, is a slot where you can take a standard serial ATA hard drive, you can drop it right in there, so you can pretty much easily pop in a hard drive there if you need to access data on it, format it, install a new operating system or anything. So that's just a easy access panel. Apart from that, you will want to pay attention to what your case looks like. It is a bit of a statement for a lot of folks. If you're putting some really high-end components, you might want to consider a case with a clear acrylic side panel like there so people can look in and see all of your hard work that you've done in assembling your computer. Another great feature of cases is a painted interior. You'll notice some cases have painted interiors, usually the nicer ones. Also, they might have this big cutout here. That is for the back of your motherboard tray, because the aftermarket CPU coolers, like the ones I showed you earlier, oftentimes you have to get at the back of your motherboard tray. If it's mounted to this and there's no cutout, you can't get there, and you actually have to remove your motherboard completely if you want to swap out your cooler. It also has some routing holes like all these right here that you can feed your cables through to keep all your cable management nice and tight, which helps the air flow through. And then finally, up here at the front, we have toolless drive bays. So this is, for example, for 3.5-inch drives like the mechanical hard drive. It snaps on like that, and then you can simply insert it into the slot. It snaps in place. You don't need to bolt or unbolt anything. Finally, they have a similar system up here for your optical drives. It's got a latching system. You slot the drive in the front of the case, pop that down, and it's held in place without the need for any bolts or screws or anything like that. Next up, moving on to the power supply category, and we have a couple power supplies for examples here to show you. A few things to take into consideration when you're looking at power supplies. One is wattage, and generally speaking, you might consider that the more the wattage, the better. That's not always the case. You really want to investigate your power supply, check out some reviews online to make sure that they're using quality internals inside the power supply. If you have a pre-built computer from anywhere else, and you look inside, chances are that is the one place that they have skimped the most. You'll probably have a very generic power supply in there, and this is the device that's responsible for taking your unruly AC power, transmitting into nice, safe, usable power for all the delicate components in your computer. So definitely something that you want to invest a little bit of time researching. A few other things with power supplies that are useful to have. 80 Plus is a not-for-profit organization that has a standards for efficiency. I should flip this over. I don't know if you guys can see, but this one has a little 80 Plus certification logo on there. It just means that the power supply is going to be more efficient, and this will save you on your power bill overall. Also, you might consider getting a modular power supply. This is an example of a non-modular power supply. You can see all of the cables are attached and they're all grouped up in this little bundle right here. What is helpful for computer building in general is a modular power supply like this one here. You'll notice just the couple essential motherboard cables come pre-attached, and then any other cables or components that you have, you can basically pick and choose which ones you need, and you plug them into the modular plugs just like that. So this really helps keep stuff inside your case a lot more managed as far as cables goes. It helps you keep from having a nice bundle of unused cables there that blocks your airflow, and it just keeps your computer looking nicer overall once you get the build all put together. Now next I'm going to talk about the CPU, motherboard, and memory, and I generally refer to these as the core components of the build. This is really the heart of your PC, and generally this is what I start with when I'm parting out a new build. You will first want to determine what processor you want to get. Make the very difficult choice between an Intel or an AMD processor. There's lots of information out there on the internet, so I won't go too far into that, but there are pluses and minuses to going with either one. From there, you'll want to go on to choosing a motherboard. Make sure you get the same socket for the motherboard that you get for the CPU. So for instance, this is an LGA 1155 processor from Intel. I want to make sure I get an LGA 1155 socket motherboard. Beyond that, I want to make sure I get a chipset that's compatible, and I also want to make sure that the motherboard has the features that I want. For AMD, it's the same sort of thing. You want to make sure you get a socket that is compatible with the processor. AMD's recent processors are very flexible with the socket that you get. So there's AM2, AM2 Plus, AM3, and the forthcoming AM3 Plus. So again, you can reference the compatibility charts to make sure you're getting compatible parts. Beyond that, you'll want to go ahead and choose your memory. Memory is pretty inexpensive these days, fortunately enough. Make sure you get a 2-pack of memory if you have dual channel memory, and if you're going with something like an X58 motherboard that has triple channel memory, you'll want to get a 3-pack of memory so you can take advantage of that. It makes the memory operate much, much faster. Beyond that, the motherboard has a lot of other components built in that you might want to consider. For example, your serial ATA ports. If you're planning to get an SSD or something faster, you want to make sure you have serial ATA revision 2 at least, preferably serial ATA revision 3, which is 6 gigabits per second transfer rate maximum, and that will make sure that you're forward compatible with the new storage that's coming out. Beyond that, if you have, for instance, a legacy device that has an IDE, maybe you want to use an old optical drive or hard drive, you want to make sure that it has an IDE connector for that drive as opposed to serial ATA. You want to make sure that the motherboard looks nice, especially that if you have a case with a side panel window so people can look through and see that your computer is all color coordinated. That's obviously not necessary, but it's up to individual preference. And then finally, you want to make sure that for instance, you have front panel connectors. These are, for instance, USB headers. So if your case has front USB ports, you want to make sure you got headers on the motherboard so you can route that cable there and make use of those ports. Beyond that, memory, processor, motherboard, get those all at once and make sure that they're all compatible. If you're not sure, check out our Egg Expert forums. You can throw up your parts that you've chosen for your build, and you can find out whether or not those are all compatible with each other and maybe get some suggestions. One last thing to mention is the PCI slot. That's these slots right here. They are PCI Express slots. Generally, you'll have at least one at the top that is a 16-speed PCI slot. Make sure you have at least that, because that's where your video card slots in, and you want to make sure that you have the maximum amount of bandwidth available for the video card. Next up is our video cards, and this really varies a lot on your intended use for your computer. If you don't do much gaming, it's perfectly acceptable to get a motherboard with integrated video. That will work for most video playback, especially the newer integrated video can even do 1080p video playback, so you can even watch your movies and everything. However, if you are a gamer, and I know a lot of you folks are out there, you're going to want to get a discrete video card. Now, video cards are somewhat interesting. We have two primary GPU manufacturers. That's the actually graphics processing unit that you can't really see, but it's right underneath there. There's NVIDIA and there's AMD. AMD used to be ATI. They were purchased by AMD, so now it is just NVIDIA and AMD. NVIDIA cards and AMD cards each have a sort of a unique feature set. Both companies produce GPUs. They're very comparable to each other. Again, this is an area where there are just a ton of products out there, a really wide range of items to choose from. So do some research, check forums, post some information and ask for feedback, and you can get a lot of recommendations for which graphics card you can go with. This, for example, is an AMD-based video card. It is actually manufactured by Gigabyte, or I should say assembled by Gigabyte. The GPU is by AMD. This is a video card that is assembled by ASUS, and the GPU is made by NVIDIA. Generally speaking, you'll just want to make sure that you get a graphics card that is within your price range. Make sure, for example, that you don't cheap out on your CPU and then get a really, really high-end video card, because you might end up bottlenecking and you won't be able to get the performance out of that video card that you want. Generally speaking, video cards will be about $150 range. There's another bracket in about the $200 to $250 range. Another bracket in a $300 to $350 range, and then the best of the best that are available are just about $500 to $600 each. But that's usually just for the newest and fastest video cards that are out there. So find one that meets your needs, especially if you're a gamer. Make sure you get one that's DirectX 11 compatible, because those are the newest ones. I recommend finding one with an HDMI out on the back, because that's really helpful for connecting it to your home theater. Next up, we're going to talk a little bit about storage. Now, we already mentioned that there are two primary types of storage devices available, the smaller and faster SSDs, the more capacitous but less expensive mechanical hard drives. It's a bit of a tough choice to make between the two. Remember, you can always add something in the future. So if you don't have the cash right now to go with an SSD, you can get a mechanical hard drive and then upgrade to an SSD in the future. That's the beauty of building your own computer, is you can add stuff on. In my personal opinion, the best setup you can get right now is an SSD for your boot drive. That's where you load your operating system, and make sure you get one that's at least 80 gigs, more likely 100 to 200 gigs, but again, they can be expensive. A mechanical hard drive you can then use for all of your data storage. So you store all your data on here. If your operating system gets corrupted or virus or something, you can wipe this SSD, reinstall your operating system, still have all your data on the other drive, and then you'll have a fresh new operating system that will be just like the day you first built your computer and installed it. If you don't have the cash for an SSD right now, mechanical drives are still perfectly viable. You can get 1 terabyte, 2 terabyte, 3 terabyte drives right now, load your operating system on that and be just fine. There's other options such as partitioning the drives and that sort of thing, but that's a little bit more complex. So for right now, those are the two options that are available. You can pretty much check the pricing and availability of these types of drives and choose which one will best suit your needs. Next up, we're going to move right along and talk about optical drives. Optical drives are fairly easy at this point, because really it's just a matter of what features you want. At the most basic level, you can get a DVD burner. They're very inexpensive, and I recommend at least getting that. A DVD burner will allow you to read CDs, read DVDs, also burn DVDs if you want to do backup or create video discs or anything like that. If you do want to use your computer for multimedia, it's very nice to get a Blu-ray drive, and actually our second build that we'll be doing in part 2 has a Blu-ray drive installed in it, so we'll show you how that works out. But basically, check the pricing. If you want the Blu-ray, go with it now. Again, you can get a really inexpensive DVD burner for now and then upgrade in the future if you so desire. But that is, again, the benefit of building your own computer. That is going to wrap it up for part 1 of our How to Build a Computer video series. Stay tuned for part 2. We'll be posting it as soon as we can. Thanks a lot for watching today's video, everyone, and we'll see you next time on Newegg TV.